understand velocity acceleration, we do need to know position and displacement. So there's basically going to be 4 new terms today. First up, position. Position is where you are. All right, in physics class, to say wherever your location is. All right. We're going to start with all one-dimensional stuff. We will move in about a month. We'll get to 2D, projectile motion, things flying through the air. We're going to have more than one dimension. But for right now, we're just going to deal with, basically you could think of it as a number line. All right. So position is where you are on that number line. Okay, you could think of a football field. Think of those markers as your position. But basically it's X marks the spot. I'm going to use the letter X. That's going to be a variable in equations. Okay, and it marks where we are. All right. The units for position is meters. So in this class, we won't use miles or feet or inches or anything like that. It's always going to be meters. Okay. So position is in meters, and it says where we are. Now, the change in position is called displacement. All right, and it's going to be different than distance for a little while. Okay, for the first month of school, I'm going to make sure that you understand how the word displacement and the word distance are different. All right, so displacement is the change in position. Okay, if you remember from chemistry, delta. All right, if you want to get all fancy pants, delta means the change in. So the change in position is displacement. Now, you hear the term displacement sometimes talking about like with people, right? A house fire displaced a lot of families along those lines. So you've heard that term outside of physics class. But it is different than distance. Okay? Displacement is how far you are from where you started. All right? Okay. I'll wait. Now, the units for displacement are the same as the units for meters. Okay? Because it's the change in position. Right? Think about change with money. Something costs $8, I give it 10. How much money you get back? $2. Right? So the change should have the same units. Units you might think are boring at first, but units are actually going to really help you understand. Sometimes the units alone can teach you what the equation was. Okay? Or as we go along, I'm going to show you how knowing the units means it's going to be a lot easier to do a problem. Okay? Anyways, so far so good? Okay. All right, now. Whoops, I already wrote that down. The difference between distance and displacement. Displacement is, again, how far you are from where you started. It doesn't care about the path, okay? But we'll go with distance, okay? Distance is how far you actually travel, how much your feet actually feel. All right, so I'm going to walk around this table. So let's say I go 1 meter. Oh, no, sorry. I do 3 meters. I'll do 3 because I wrote it up there. So let's say I walk 3 meters, and then I walk 1 meter. And then I walked 1, 2, 3 meters. And then I walk 1 meter. Okay? So I start and stop in the same spot. What was my distance? How far did my feet actually travel?
8 meters.
Right, 3 plus 1 plus 3 plus 1, 8. All right? What was my actual displacement? How far am I from where I started?
0.
0. Okay? So, my distance is how far you actually travel. It's what your feet actually had to do, or what your car drove. All right? That would be what the odometer really shows. All right? And it does not care about direction. That's going to be important later on. All right? So I walked 8 meters. No matter what. I could have gone 8 meters in a straight line, or I could have done 8 meters around in a circle. I still had the same distance. But my displacement is different. Okay, my displacement is just how far I am from where I started. I started and stopped in the same spot, so my displacement was 0. Okay? and it does care about direction. Direction is actually important. If I say that I walk 3 meters in this direction, okay, well then if I go 3 meters in the opposite direction, I might even say it's negative 3 meters. Okay, distance will be important. Okay. You want me to wait? I can wait. I'll pause it. We're good? Am I recording? Yeah?
Yep.
Okay. So I'm a physics teacher. I'm legally obligated to test you on whether or not you know the difference between distance and displacement. Okay? So you can expect a question like this on a quiz or a test. Okay? You could also expect a question where you don't go around and start and stop in the same spot, but let me take a step back. So again, you can expect that I'm going to give you a question that says, what's the distance, what's the displacement? Alright, and if I start and I stop in the same spot, the distance is what your feet actually feel. The displacement is going to be 0 if you start and stop in the same spot. Now, if I just go, let's say I go forward and backwards. Let's say I walk 2 meters this way, and then I turn around and walk 3 meters that way. Okay, what's my distance going to be? If I walk, I'll say the number again, 2 this way, 3 that way.
5.
So my distance is 5. What's my displacement?
-1.
Right. I like -1. I would not say you're wrong if you said 1. I didn't specify that this way was negative just yet. Okay? -1 is maybe more specific because it even has a little bit of direction in there. In this class, negative just means direction. Okay? Every now and then, like especially if we do a pop fly, we're going to have something go up in the air, come back down. I'm going to say up is positive. If you do all these calculations, you figure out the velocity is negative, that means it's going down. Okay, so negative just means direction. Okay? But there's a good chance that you're going to see a question like this as well. Okay? Possibly even soon. I might even have a little one, we used to call it CFAs, I might still call it CFAs, a little one question quiz. Might be like this or might be like that. Okay? And it's just, after September, I'm not going to be asking about displacement versus distance, but I just want to make sure you understand. Cool? Cool, alright. Now, speed versus velocity. Speed and velocity are similar. Outside this classroom, alright, we're just talking, you're not taking physics. You could use the word speed and the word velocity. It's pretty much the same thing. It's just how fast you're going. Okay? However, in this class, speed is a little bit different than velocity. Speed is like distance, velocity is like displacement. In fact, speed is distance divided by time, okay? And velocity is displacement divided by time. Now, still would be, the speedometer in your car tells you how fast, right? It could tell you the speed. You could also say it's telling you the velocity. But if you start and stop in the same spot, they're going to be different. Your speed and your velocity is going to be different. All right. The units for, let me just say, velocity is speed and direction. So you also, speed does not care about direction. Okay? Velocity does care about direction. So again, if I say something has a negative velocity to it, it would just mean it's going down. It's just pointing down. Alright? The units for velocity are meters per second. Again, we're not going to deal with miles or feet or inches in here. It will be meters. So when we talk about velocity, it's going to be meters per second. Just so we know, this is a meter, right? This is 1 full meter. So this is, when we talk about 5 meters per second, that means you're traveling 5 of these per second. You're used to what miles per hour are, right? But sometimes meters per second, that's all it is. It's how many of these per second. Okay? Alright. So, the way we could do a formula for velocity is this. Velocity is displacement divided by time, okay? Or if you want to get fancy pants, change in position over time. Okay, so I'm going to ask you two questions. I'm going to post it here in a second. The two questions are this. For you to talk with others at your table, or you can move the table. Can velocity be 0? And can velocity be negative? I'm going to let you talk. Alright, so can velocity be 0? Okay. So, can velocity be 0? Yeah. Two ways it could be 0, okay? My velocity is 0. I'm not moving. Now actually, technically, you could say it is moving and Earth is spinning, so I am moving somehow. We're all moving. But, you know, my velocity is 0. I'm not moving right now. What's another way that we can say the velocity is 0?
And back at the same spot.
Right. If you start and stop at the same spot, your velocity is 0. I usually give a question about, say, like a race car driver. You know, and I'll say, what's his speed and what's his velocity? So you'll do all the calculations. I'll say how long the track is. All right. You'll do the distance divided by time. Is that the speed or the velocity? Speed. What would his velocity be?
Displacement 0.
0. If he starts and stops, you're saying it right. If he starts and stops in the same spot, his velocity will be 0. I'm going to give you a question. Okay, I'll give you a question on the test like that. So look for it. You see something where a person's starting and stopping in the same spot, I'm really asking you to tell the difference between speed and velocity or distance and displacement. Okay, and again, if you start and stop in the same spot, your displacement is 0 and your velocity is 0. Okay? All right. Acceleration. Yep.
Can it be negative?
Oh, sorry, yeah. Oops. Yes. Because in this class, negative only means direction. Okay? So in this class, we could be talking about velocity, we could be talking about acceleration, we could be talking about force, whatever it is. You could have a negative answer. And that negative answer just means it's the opposite direction of the positive. Alright? We're going to talk about gravity. Alright? When we're talking about gravity, gravity is going to be negative. Okay? If you do calculations and you end up with gravity being positive, that means it's pushing it up. That ain't going to work. Okay, so when you're doing the calculations, negative is important. And so yes, velocity can be negative. And it just means it's the opposite direction. Easy enough? All right. Now, acceleration is different than velocity. When students are first working on velocity and acceleration, they can get confused between the two. All right, they're exclusive. You can have something with velocity and not have acceleration. You could actually even have something for a split second of time. You could have something with no velocity or a velocity of 0 and have acceleration to it. Okay, so there are two different things. Velocity. You can never ever feel velocity. You can never feel how fast you're going. Okay? Let's say you're driving your car. Windows up so we don't worry about wind. Alright? If I'm driving my car, got the AC going, there's no way that I can feel if I'm going 15 miles per hour or 100 miles per hour. I can feel myself speeding up and slowing down, which means I can feel acceleration. But I can't feel velocity. Think about it, you're on an airplane. You're going about 200 miles per hour. Does it feel like you're going fast? No. Right? You can never ever feel velocity. But you can feel the speeding up and the slowing down. You can feel acceleration. Alright? They showed them in the video, they showed, you know, something hanging from the rear view mirror It's going to swing forward or swing backwards. So you could actually even measure the acceleration from that if you wanted to. All right? We won't do that now or anything. Roller coasters. With roller coasters, they do have, I mean, they care about how fast you're going. I mean, for one, because most people understand speed, you know, say miles per hour, they don't understand acceleration. And yeah, you're flying through the air, so you feel the wind in your face. The faster you go, you feel that. But really, you know, roller coasters are designed for their acceleration. Not for how fast they're going to go, but their acceleration. Does that make sense? You know, you feel all those, they talk about G-forces. How many more times of gravity? And that's acceleration. Has anyone been in one of those, what do they call them, 4D things where like you're actually just in a movie theater, but you're in a chair that moves?
Yeah.
You know what I'm talking about? Okay. So what are they doing, right? They show in the movie that you're accelerating, going really fast accelerating. What do? Just that, right? But when they accelerate your chair, what they're actually doing, they're leaning back that chair, and so now you're feeling some of gravity, okay, pushing you in your back in your seat. And so it tricks you into thinking you're accelerating. It's actually the same exact thing, because gravity is just acceleration. So when they do that, you feel yourself accelerating back in your chair because it's the same thing. All right, then all of a sudden they show you slam on your brakes and you lean forward, right? So you feel like you're slowing down, where really they're just doing this. Okay? Because gravity and acceleration are the same thing. Cool? Cool? Okay. All right. The units for acceleration are meters per second squared. Don't get confused. When you see meters per second squared, a lot of students at first are going to think that you square the number. Okay? This is just like a stamp. Okay? It's just like a symbol. It could have been dollar sign for all we care. It's just a symbol that tells you that we're talking about acceleration. That's it. Okay, so if you see something, absolute value? Is that?
You said it has absolutely nothing to do with it, right?
No. Now, I mean, it shows what's going on in the formula. You can see why there's a squared because of what happened and how you calculate it. But no, that is just a symbol telling you what it is. Yeah. All right. So the units of acceleration are meters per second squared. Now, I want you, with your friends again, or if you don't have any friends, just somebody else, go ahead and figure out, just come up, see if you can come up with a formula for acceleration in terms of velocity and time. Okay, just see if you can. All right? Okay. So, acceleration is the change in velocity divided by the time it takes to make that change. Did we do all right? All right, that's fine. So, it's the change in velocity, right? You go from 5 meters per second to 25 meters per second. Your change would be subtracting those two. But it's important about how long it takes to make that change, okay? My car might go 0 to 60 in about 2.5 hours, okay? Yeah, that would be terrible.
That's terrible.
Okay, while the Porsche goes 2.5 in, or goes 0 to 60 in 2.5 seconds. You're going to feel the difference, right? The Porsche will have a much better acceleration than my car. So it's not just the change of velocity, but how long it takes to make that change. Fair enough? Okay, so if you want to get all fancy pants, there you go. The change in delta V over T. But it's the change of velocity divided by the time. All right. Can I go on? Okay, here is a very important list. So I call it the very important list. You're welcome. You're welcome, America. Okay. Now, here's why I do this. It's going to help you. Okay, I think you want to have this list, and later on you're going to put it on a yellow sheet of paper. I'm going to give you the yellow sheet, and you'll have that for every test, quiz, homework, final exam, everything. Okay? But when we're working along, it's easy if we can just organize what we have to start with. It's going to make your life a lot easier, okay? There's other ways it's going to help too. Let's say you have a test, okay? I'm going to tell you right now, in every big quiz or test, I'm going to give you the at least first 4 questions of the test are going to be units. What are the units of velocity? What are the units of displacement? All that, right? So at the very least, when you start that test, when I say what are the units for velocity, you're going to look at your sheet and go, oh, meters per second. I mean, that's simple. And it always makes me cry when the student gets the unit questions wrong on a test. All right? I go home and cry. But actually, there's more to it than that. When you are doing a word problem, I know nobody likes to do a word problem. Okay? But when you do a word problem, if you have this sheet next to you, you have your list next to you, and you start reading through the questions, okay? You read through a question, you say, all right, a car is traveling 15 meters per second. Well, you go, oh, 15 meters per second. Oh, he's talking about velocity. So then you could write v equals 15 meters per second underneath. And then there's an acceleration of 2.5 meters per second squared. So you go, oh, 2.5 meters per second squared. He's talking about acceleration. All right, so a is equal to 2.5. So what it's going to do is when you're given a word problem, even if or basically this could dissolve away all the words, and you're just left with the numbers and the units, and you can say, oh, okay, I know how to do this problem. The biggest thing that people say when, the first month, when students have concern, one of the most common concerns will be, I just don't know which formula to use. Okay, but what we're going to do is we're going to show you how to just look at the numbers and the units using your very important list and say, oh, I'm going to pick this formula because that's what you're giving me. Okay, it's going to be a lot easier. All right, that is it. I'll leave that up for a little bit. Anyone have any questions about that?
No.
No?